Hello everyone. This is in continuation to our various videos on probability distributions, in which last we had seen about normal distribution, different types of problems. This is one more problem in normal distribution. There are 600 business students in the postgraduate department of a university, and the probability of any student to need a copy of a textbook from the university library on any day is 0.05. How many copies of the book should be kept in the university library so that the probability may be greater than 0.9 that none of the student needing a copy from the library has to come back disappointed? So if we look into this, they had given us the number of students. So first let us write, let the number of students equal to small n, and that is given as 600. Okay, then they had given us the probability of any student. So let me put small p as probability of any student to need a copy of a textbook, copy of a textbook on any day from the library. So that is given as 0.05. So if you look into number of students, I can compare this as number of trials, and this probability of any student to need a copy of a textbook on any day from the library can be considered as a probability of success. So I can very well say then Q is equal to 1 minus of P, which is 1 minus of 0.05, which works out to 0.95, right? So now let us proceed to the next slide. So one thing is clear from this, that this probability of success, whatever it is given, that should be always, every time when I do a trial, or every time when a student comes, the probability remains the same. It doesn't change. It is the same. And then either the student gets the book, do not need a book, or do not need a book. There are only two mutually exclusive events. So I can very well say, let me first define what is our random variable. Let capital X equal to a random variable which denoting number of copies of a textbook required on any day. Now, already we had seen that the events are mutually exclusive, and only two events are there. Either it can be success or it can be a failure, right? So that means I can say very well, it is clear that X is following a binomial distribution with the parameters n and p. Now we may note, we know, sorry, we know that mean of a binomial distribution is n into p. Let me, since it is mean, I will call it as mu, and it works out to n is 600, P is 0.05. So if we multiply these two, we get 30. Then we have standard deviation of a binomial distribution is square root of NPQ, which is square root of 30 into 0.95, because 30 is your N into P, and Q we already know it is 0.95. So that we will get 5.34, right? So we may note that NP, which is equal to 30, is greater than 10. And this variance of a binomial distribution, which is without square root, means NPQ is definitely, see, square root of NPQ is 5.34. That means square of this 5.34 will be more than 25, definitely. So you need not calculate that. So I can say that also is larger than 10. And when NP is larger than 10 and NPQ is also larger than 10, hence we can approximate a binomial distribution to a normal distribution, or to be very specific, standard normal distribution, as follows. So we will bring in that standard normal variate, which is our Z, and we know that is X minus mu divided by sigma. What is sigma? This is sigma, standard deviation. So it is nothing but X minus of, what is that? We have this 30 is our mu, and the sigma is 5.34. So that becomes our Z value. Now, what is the question? Question is, if the probability is larger than 0.9, how many books needs to be kept in the university? So let us go back, go to the next page. We need to find, let us say, small x such that probability of x equal to small x, or I should not put it as equal, it is better, let me put that as greater than, so because it is minimum number of books. Or I should say less than. This is the maximum number of books what we can kept, and that probability has to be larger than 0.9. Why I have put less than x? Because this is actually the number of books what we are planning. That should be the maximum number of books, right? So that this can be met with, the probability exceeds this. Now let us bring the conversion, which is subtracting both sides by mu, dividing both sides by sigma. Mu is 30 and the standard deviation is 5.34. This should exceed 0.9. So I can rewrite this as probability of Z less than, let us assume this particular thing, entire thing, as some small z larger than 0.9, where the small z is equal to x minus 30 divided by 5.34. Now, how do I represent this in a graph? You have to draw a standard normal curve, means bell-shaped curve. This is negative infinity. This is positive infinity. Center line, sorry. Call it as 0. Okay. This probability should be 0.9. That means somewhere here our Z1 will come. So the total area I will express like this. Now we are supposed to identify what is that Z value. I should put it as Z, not Z1. Because there I put it as Z only. So, right. This entire area is 0.9. Right. So I can now split this probability as probability of negative infinity less than Z less than or equal to 0 plus probability of 0 less than Z less than small z, and we can even put this as greater than or equal to, less than or equal to everywhere. Yeah, so I can put here as this. This should exceed 0.9. We know this value of this probability is 0.5 plus probability of 0 less than z less than or equal to small z. This should be larger than 0.9, or probability of z less than z less than or equal to small z should be larger than, take this 0.5 from the left side to right side, it will become negative in the right side. So 0.9 minus 0.5 will become 0.4. Now from the tables, from the normal distribution tables, we can get the value of the z as 1.28. Now, so I can say z is equal to 1.28. What is z? Already we simplified that here. X minus 30 by 5.34. X minus 30 by 5.34. So now cross multiplying and finding the value of x, we will get x as 36.8352, which is approximated to 37. So the question is what? That is our how many copies? So number of copies to be kept in the library. Therefore, the number of copies to be kept in the university library should be 37 numbers. So that is our solution for this question. So in this, what is different in this question? In this question, actually, the given problem is following a binomial distribution. But since this n into p is larger than or equal to 10, if the condition is if n into p is larger than or equal to 10, and n into p into q is also larger than or equal to 10, we can approximate a binomial distribution to a normal distribution. That is what we applied in this particular problem, so that it becomes much more easier to refer to the tables rather than doing some calculations to find out the number of copies, right? So in case if you find this contents of these videos to be worth it, then I request you to please like, share, and subscribe to my channel.